Y'all didn't hear a thing I said, did you?
Not a single word.
But you were going to town, man.
I was like, yes, and I'm muted. Okay, well, we're going to talk about Chapter 3 today in our Connecting Networks class. Now that I've successfully turned my, oh my goodness, turned the voice on. The good news about this chapter, it is neat because they've added some stuff to it, and it's different from anything we've seen. We're on track right now because the labs for this chapter are not due until the, I believe it's the 18th of March, because there's only 8 chapters in this particular course, Connecting. So the other thing you need to be doing is realizing that as you're finishing up these chapters, if you do get done early, start studying for your CCNA, for the ICND2. And if you have not already completed ICND1, obviously you need to do ICND1 too. But we're going to look at several things here. We're going to look at pppoe, we're going to look at GRE, we're going to look at some VPNs, and we're going to look at BGP, which is totally new. It's actually something that used to be on the old Discovery curriculum in the Cisco Academy, and they moved it into this, which I think is a really good idea because it is needed, that you have at least a basic understanding of BGP. BGP is a huge CCNP topic, so it's one of the main things in CCNP route, which is one of the 3 different tests needed for CCNP. CCNP has CCNP route, CCNP switch, and CCNP troubleshoot as of the time of this recording, which is 2018, early 2018. First thing we want to do is talk a little bit about the 2 most prominent types of connections to teleworkers at home and to your internet at home. That is a cable system and the DSL system. One of the things we see here is how an antenna site is used to bring in information to the head end, and then the head end is used with trunks for amplifiers that go out and will eventually be taken out to a subscriber drop. Now, one of the things that you learn about a cable system is that a cable system does have a cable modem termination system, which is an exchange that takes digital signals on the cable network. It has fiber that goes out to a node that is normally located either in a neighborhood, which is in a distribution area, which then goes out to coaxial cable, or possibly there's a node that converts from fiber to a physical cable somewhere in this coaxial cable, because typically the final mile distribution on all cable modems is going to be a coaxial RG6 cable. One of the issues with cable, now one of the things I would tell you right now, if I have DSL at home, and if I could get a cable modem, I would get it in a heartbeat, because I can only get 11 megabits per second at home with my DSL, and that is because of where I live. You know, the beauty is I can go out in the backyard and see cows. The negative is I have very slow internet. Cable modems, however, sometimes, for me it would be great, because if I could get the cable run the last half mile to my house, I would share it with 2 or 3 other households. So I would have a large amount of bandwidth. The problem with cable modems you have to be careful with is, especially if you live in densely populated areas, because what happens is they'll bring in, I don't know, let's just say they bring in even 10 gigs into this distribution area. But then from the distribution area, they go out to 500 subscribers and give each one of those 100 megabits per second or 200 megabits. So you think you're getting 200 megabits right here, and you think that goes all the way back. But what has actually happened is they've oversubscribed the link from the distribution area back to the CMTS. And the end result is you really don't get the speed you're paying for. Now, again, that's typically only a problem if you have a dense population in the area. Now, you know, the good news is the standard was what's called DOCSIS, which is the standard for cable modems, and that's down there. It's called the Data Over Cable Service Interface Specification, or DOCSIS is the international standard for using the extra bandwidth on the coaxial cable for data. But the new DOCSIS standards do allow bandwidth for up to 10 gigabits per second, all right, which is pretty quick. And that's 10 gigs downstream and 1 gig upstream. So if they've got a big enough bandwidth to the distribution area, then you can have really, really, really fast internet with a cable modem. But again, it goes back to you've got to make that decision. Now, what they're doing, if people go, well, why do they oversubscribe? Well, the guess is, and not necessarily rightfully so anymore, but the guess would be that not everyone's going to use their full bandwidth. But then, in today's households, you've got Sonos downloading some or streaming music. You've got a Google Home streaming music. You've got two kids watching two different things on Netflix and somebody playing on an Xbox. And suddenly, you really are using all the bandwidth that you are supposed to be paying for. So, one of the things that I really see, especially in rural North Carolina, is a huge disparity between speeds of internet connections. And I'm really starting to see that it is greatly affecting the economic mobility of people. It's actually affecting me because I can hold these sessions from home, but I'm in the office because my internet at home is not fast enough to actually run these sessions. So it is something that needs to be addressed, and I'm not actually sure how it's going to be addressed. I have some ideas that actually are talked about a little bit later in this particular class. What I have at home is DSL. Mark, what do you have, DSL or cable?
I've got cable.
How fast is it?
300.
That's pretty good. That's pretty good.
But like you were saying earlier, I've got 750 homes over there too, though.
Right. So that's the question is, what do you normally, have you ever done a speed test to actually see what you get?
I run both speed test and fast.com so I can see what is coming through the stack too.
Okay.
And we're getting usually about 323. And then when you use, and that's what I usually like to say is coming in the pipe.
Right, right.
And then I go to fast.com because that tells me what my browser is actually yielding.
Gotcha. So I found this one not too long ago I kind of like too. It's called Speed of Me. And what I like about it is it changes the size of the sample. So if you have an MTU problem, or if you have an issue, here's a 64 meg sample, you see what it's doing is changing the size of it to see if there's a difference, a drop in speed based upon the size of the sample. What was that other one you used, the one for the browser? I like it.
It's called fast.com.
Fast.com?
Yeah, it's by Netflix. So if you have a student,
okay.
See what it's just it shows what your browser is actually providing.
Gotcha. Okay. Oh, that's cool. Yeah. Hey, you just taught me something. That's neat. I like Speed of Me, but that's cool too. So you got faster at home than I got at work. Huh.
Yeah, but I mean, I pay for it, man. It's like $110 a month.
Oh yeah, it's expensive, but trust me, as somebody who gets 11 megabits per second, I would pay for it. I do need. Actually, I like that. I'll test mine at home and see what I get. That's a good one. So those are two ways to kind of look. DSL is more widely available because it is run over the POTS or plain old telephone system. They carve out a piece of frequencies, and there's two different types of DSL. 99% of it that I've heard of is ADSL, which is asynchronous digital subscriber lines. And asynchronous means there's more bandwidth or more frequency carved out for downstream than upstream. So it's asynchronous. In other words, you've got a faster downstream than upstream speed, which for most connections works fine because most of your information is coming down to you. There is and has been a specification called SDSL, or synchronous digital subscriber line, and that would be the same speed up as down. Not very common anymore. Now, you can get up to 40 megabits per second. I've heard some rumors that you could get faster. But the real negative is this right here. In fact, up to just very recently, I actually only had 3 megabits per second. And I basically talked the phone company into putting a repeater between me and the switch so that we could get faster speeds. And I had to basically get neighbors agree to increase their speed so that we could get them to put in the repeater. Now it's just a matter of convincing the cable company to run a cable quarter of a mile. Either that or we're actually talking about maybe running some kind of wireless signal between a couple houses. DSL connections, you see here, obviously you've got a PSTN network and the DSLAM, and that DSLAM or the PSTN switch, but the DSLAM is what you're actually connected to for the digital subscriber line. But the DSLAM is located in the carrier and it has individual DSL connections. Now, one of the amazing things is when you get a hold of a phone company and you talk to them and you talk to them and say, hey, guess what? I don't have the connection to the DSLAM. I'm not, oh God, what's it called? Oh, it's killing me. Basically, you're not syncing up with the two different. At one point, I had one of my two separate lines going to the DSLAM quit working. But this link here, it does have to be maximum of 339. I think it can go a little bit further now, but still, to get any type of decent speed, you've got to have, you've got to be close to the DSLAM. Couple different ways of doing it. 810s, 890s. These are all Cisco actually made DSL routers that you could buy, and this is a broadband aggregated for multiple routers. This may be the savior of all of us, and that is right down here, 5G, as I keep mentioning in all my classes. 5G, I can actually get, believe it or not, faster access from my phone's hotspot than I can from any wired technology that comes to my house. The negative is, even with unlimited bandwidth, when you pay for unlimited, you're really not getting unlimited. You're getting a certain amount for your hotspot. In fact, I've got 10 days until my hotspot can actually go back up to fast speed because I downloaded something really big off of my hotspot on my phone. They are working on 5G, and 5G is going to be, to use a non-technical term, stupid fast, and it's coming out. It's going to be there. We just got to see where it's going to come out and how it's going to work. Satellite is a possibility if you're in the boonies. Mobile broadband is some of the Wi-Fi stuff that's around, but it's really LTE has replaced WiMAX, so you don't really have to worry much about it anymore. Two-way satellite. This is used a lot by combat units in the field. So if you've got units, even non-combat units, but units deployed in the military in the field, they use a lot of satellite communication. Oh, I will tell you this, something cool about satellites. If you've ever heard of SpaceX, which hopefully you have, recently they launched a Falcon 9. They actually launched 2 Falcon 9s here recently. Been in the last 2 weeks, 2 or 3 weeks, they've launched 2 Falcon 9s. But on one of the Falcon 9s, they deployed a normal satellite for a vendor, and then they deployed 2 of their own test satellites. And what they're going to do is they're actually going to try to put, I don't know how many, but a large number of small satellites in orbit over the U.S. And by doing so, provide internet access via satellite to the United States, anywhere in the U.S. And then they're wanting to use those funds from that venture to turn around and fund their Mars mission, which is kind of cool. Comparing broadband, obviously cable has very high bandwidth, but it is shared. So sometimes during high usage hours, you get some oversubscription issues. DSL is limited bandwidth that is sensitive to distance. Very big problem in rural areas. Fiber to the home is the dream, okay? But recently, if I'm not mistaken, I think Google Fiber actually stopped their Google Fiber initiative. Pretty sure that's correct.
They do.
Yeah, and that's very interesting to think about a company that they were rolling out all that and then they stopped it. Do you know why they stopped it?
Yeah.
Why is that, Mark?
My son works for Windstream, and he was telling me that whenever they would request somebody to come out and show them where their lines were, they would not come out. They'd say, you're going to have to contact this company. It would take 2 to 3 weeks. Right. So Google would turn around and start cutting. And then they cut constantly.
They cut stuff. Well, and also the other thing there too is I heard the big reason was that they were looking that there was going to be honestly wireless technologies that were just as fast. And so by the time they laid all the fiber, then they were not going to have any better speed. Now, I will say this, in some housing developments, they've actually run fiber to all the houses, and then when you go back and look at this, and I hate to jump all the way back here, but when you go back to this, distribution area, this has, instead of coax to the houses, it's all fiber to the houses. Not a lot of that in this area, but in California and other places. So that's one way. But also, like I said, there's a lot of the mobile data seem to be maybe the way to go.
Well, AT&T's coming out too with gigapower.
Right.
Which that's fiber, but they're slowing down too. But they're still supposedly AT&T will have fiber to the home in, I think it's like 65% of areas in Charlotte, supposedly by 2020 or something like that.
And the thing about that is, it's almost like the way Ethernet blew, just kept getting so much faster and ended up overtaking token ring. You look at the fact that we just keep seeing these, 4G, 5G. We keep seeing these cellular technologies be able to carry more and more data. It's interesting. It would be hard if you were a company making that huge investment in fiber to the home. It's one of those things where it's back when we had Concord Telephone. I think if we still had CTC, we would actually have fiber in our homes now, or in a lot of places. Once Windstream kind of bought it, it kind of went sideways, but that's a different story.
Yeah, I'm sure it's bad company.
Yeah. Thank goodness I almost took a job with them right before they got sold, Concord Telephone. So I didn't do it, so that was a good thing. Let's talk a little bit about pppoe, power point-to-point protocol over Ethernet. First off, quick question. What are the two different modes of PPP? We talked about them when we talked about Chapter 2. There's something that does establishment and control and termination of the session, and then once that's done, it passes it up to something that talks to layer 3. By the way, pppoe is a layer 2 protocol. All right. So do you remember the two portions of it?
I don't know that one. No, I don't know that one.
LCP. So you had the link control protocol. And the reason you need a link control protocol is because PPP was actually developed to run over dial-up interfaces. So you got to have a way of establishing the connection, maintaining it, and terminating it. LCP also does things like compression, encryption, multi-link, those types of things. And then you had NCP, which is your network control protocol.
I remember the network control protocol.
Yep. And that talks up to whatever, we've got IPCP, which is basically your IP, works IP control protocol, and we'll see that in a little bit. Especially with DSL, what telcos want to do, and you can also do it with others, but pppoe, you do it on Ethernet, runs Ethernet. But they wanted a way of taking, instead of just PPP, they wanted a way of running, and this right here should not be a serial line. This line should be an Ethernet line, okay? Because it's point-to-point protocol over Ethernet. So we're not really going to do what they're talking about here where you strip it off. You could, it's possible, but you're not going to run pppoe between the DSL modem and the user. You're going to run pppoe between the DSL modem and the telecom. So we switch the page here. This is what we're looking at. We want to create a tunnel link between the DSL modem and the ISP. So what we do is we figure out a way to take PPP and tag on the head of it an Ethernet packet. Now, the good news about that is it will now support authentication with chat because it's PPP. It will support link management. It could support multi-link. Nobody's using that. Well, technically, you could use it if you were using multiple links. So if you had more than two, you could do it. Well, even you could use it with two. But the big thing with pppoe is once you're running it, you've got a little bit of an issue with the size of the packet because it's Ethernet. So if you run this and there's an Ethernet header out here and you run it over an Ethernet network, well, you've got a maximum transmission unit, an MTU, typically around 1,500 bytes for Ethernet. We're going to create for pppoe, this is on a customer router, and this is basically what we do here. You create an interface dialer, which again confuses people because they're saying, I'm not dialing, I got Ethernet, what am I dialing for? PPP was designed to be a dial-up protocol. So you do interface dialer, encapsulation PPP, and do IP address negotiated. This means grab your IP address via DHCP. You've got a chat host name and password that you're going to pass over for authentication on whatever authentication system being used by the ISP. That, PPP could pass it to something else, or it could be a local database. In our labs, we use a local database. We change the MTU, okay, so that you can have the PPP information behind the Ethernet header. We create a dialer pool, and then that dialer pool references the Ethernet interface that's going to have pppoe enabled. And then this says be a client using the pool number 1, which applies the interface dialer 2 settings. Now, I wish they would have made the dialer 1 the same as these, but they don't. These don't have to match. Dialer number and pool number do not have to match, but the pool number has to match the pool number on the physical interface. So, once you do this, you can actually do show IP interface brief, and you will see now that I have a dialer interface, has a negotiated IP address from the ISP, and it's running IPCP. In other words, it's gone through the network control protocol, and it is actually running the IP control protocol. And it's up. So it's just another interface that happens to be running PPP encapsulated on the gigabit 0-zip-1 interface. Show interface dialer, you can see that your MTU has been set to 1492 and that you are indeed using PPP, and LCP closed. That actually should probably be open. Okay. And then you can look and see that you've got a static route. Okay. And that actually usually comes back, you have to put a special command on the PPP server to have it inject a route back. And you can actually show the pppoe session. So show pppoe session. So it's not that big of a deal to set up. I think the big place people get in trouble is they forget to change their MTU settings, or they do something wrong in the authentication process. So they mistype the username and password. The other thing I've seen a great deal is telcos who support multiple areas from a single call center and don't understand, hey, the customers in this area don't use pppoe. And they're like, well, you need to put in your authentication. I'm like, yeah, I don't need that because I don't use it. And we don't use that in this part. So that's something that's, then you basically have to say, please send me to your level 2 support. Here you can see LCP state is open. That should be good. Here's chat success. IPCP is open. So basically, here's your LCP status. Goes down. Once that's done, then you get your NCP status, and then you're getting your route injected back. Here's your chat configuration, just to make sure you can check it by doing show running config section interface dialer 2, which saves you time to go through the entire config. Or you can do debugging, and you can actually see that it's successful. So the state is open, or unsuccessful, authentication failure. This would be if you're debugging, you're actually debugging PPP negotiation, it's failing. If it is failing, you should get a message telling you it is failing. Very simple. Again, here's the problem with pppoe with segment size. You've got a 1460 payload that's 1,500 bytes total. Well, the problem then is as soon as you chuck on the pppoe, you're bigger than 1560. So you got to back this down. Since pppoe is 8 bytes, you need the MTU to drop down to 1492 so that your IP MTU doesn't exceed 1,500 bytes, and that will also ensure that everything is hunky-dory. You can also do it on the physical interface if you want to change it there. Okay.
Is this as deep as it looks, or is it just, it's a little, the biggest problem is your MTU size is what it looks like to me.
Yeah, I mean, honestly, I would say the biggest problem 99% of the time would be authentication.
Okay.
You know, people, and it may not even be here. It may be over here at the ISP. You know, many times I've heard and seen where they run pppoe. You know, this part's not hard to set up, MTU 1492. It's not a big deal. But the problem is this database over here is not correct. And because the database is not correct, you're putting in your username and password for a chat, and it's not going to work no matter what. Now, most of our modems, we have a, you have a web interface that you put in your pppoe sections. So this is only needed if you're setting up a Cisco router to do pppoe. If you're setting up a home router from someone who's using pppoe, it's already got the MTU set for you. You don't have to worry about that.
Okay.
Let's talk about VPNs. I get tickled because you see companies build these huge headquarters, and then everybody works from home. If I owned a company, one of my number one things would be, hey, let's try to make everybody work from home so I don't have to pay for large buildings and I have to pay for energy and everything. One of the ways you can make that happen is through the use of VPNs. The good news about a virtual private network is you can use existing internet to do secure communication over the internet. I saw an interesting thing on TV. I think it was my first ever TV ad that I saw for a VPN solution for the house, where you could hide all your information that you were sending from your ISP. And I don't remember which one it was. It was either Web VPN. It was one of the, wasn't Web VPN, but it was one of the well-known VPN vendors online.
Was it PIA?
I don't think it was PIA. Is Nordic one?
Yeah, I think so.
For some reason, I was thinking it was Nordic. Maybe not. I can't remember at the time. Right now. Again, benefits, cost savings. You don't have to hold those large banks of modems for people to dial into anymore. It's scalable because you can just add more bandwidth at it if you can. It's got broadband compatibility, and it's secure because if you use the correct mechanisms, your connection will be secure across. Plus, there are multiple ways to connect. You can put a client software on a machine and connect using it, or you can actually use SSL and do SSL VPNs, which they don't talk a lot about here, but you can do that. There are two types of VPNs. One is a site-to-site VPN. In this, the endpoints are devices controlled by the company. In a site-to-site VPN, the original IP header is overwritten by an additional VPN header. So you don't, there's no way to expose the internal IP address header in this VPN if it's secured using like IPsec. But this is common, again, between two devices that are controlled by the same company. So if you had a remote office or two offices in two different cities. This will not work with telecommuters, or at least it won't work with telecommuters that move around, because you need to, in a remote access VPN, terminate the VPN at a different place. You'll see here the termination happens on the client device. And again, this can be with Cisco's AnyConnect software. It can be with the Global Protect software from Palo Alto Networks. It can be an SSL VPN, so just a web browser that connects to an SSL VPN terminating device. So all of those, and that's the primary difference between these two, okay? The endpoint and the fact that the original header is overwritten in site-to-site, and it is not in remote access because you cannot overwrite the header because you don't control the devices in the path. So it has to use the original IP information. Now, DMVPN, this is, we'll spend just a few seconds on it, but basically DMVPN, the big thing though here is it uses NHRP, Next Hop Resolution Protocol. multi-point generic routing encapsulation, and IP security. DMVPN creates NHRP hubs, and then the spokes dynamically register with that hub, and then tunnels can be brought up using MGRE and IPsec. It's beyond the scope of this class, but be aware that it's out there, and it will not. It also allows not just spoke to hub, but you can do spoke to spoke. So in other words, if you've got the spoke to hub set up with DMVPN, and spoke A wants to talk to spoke C, but you haven't actually created the connection, spoke A can, through the use of the hub, discover spoke C and then create a dynamic VPN connection over to spoke C.
Is that to increase availability? Is that what that's for?
Yeah, increase availability, and also you think about if you can do your VPN instead of having to make it go to the hub and down to spoke C. If you need to speak spoke C, it's better to have a tunnel going directly to spoke C, but without having to manually configure that tunnel, on every single one of your spokes. So if you got 100 spokes and 2 or 3 hubs, you can make it to where those spokes can talk to each other dynamically without having to build new actual defined static tunnels to each one of the spokes. So like I said, imagine you had 100 spokes. On spoke A, you would have to put 99 different tunnels to go to those spokes. But with DMVPN, you can set it up where they can dynamically learn each other.
Yeah, almost like it's a full mesh network. You get it all the
Yeah, very similar, very similar. But with IPsec or MGRE tunnels with IPsec. So basically running IPsec inside of a GRE tunnel so that it is secure. We'll learn here in a few minutes that GRE is not secure. So
now, just one more quick question, super fast.
That's fine. Go ahead.
You said this is it's not covered in this class, so I'm assuming it's outside the scope.
Right.
That would be covered at what, the NP level?
Yeah, CCNP level. It's in CCNP.
Okay.
It's covered. This one's covered in routing too, I think.
Okay.
It's still not covered super in depth in routing. It is a topic that really you have to kind of go outside of just the routing and look at. But it is in routing. I do know that.
Okay. Right.
In fact, let me real quick, because I am actually interested myself.
See, now I've done sent you down a rabbit hole. I'm sorry.
Oh, that's all right. That's no problem. That's a good thing. That's a very good thing.
I'm just trying to determine how far out of scope, because I have students that ask a lot of questions about going to East.
Right, and honestly, some of your students will probably have this in their environment, and they'll be interested in it. It is for what we do. We don't get very in depth on it. For CCNA,
Okay.
it's slow, but it's working. It's trying to. Hold on one second. Where's that? All right, here it is.
Do you guys offer CCNP training?
We do. We don't offer it a lot simply because we've got. Yep, DMVPN is definitely in there. It's on 10% of the exam. DRE, DMVPN, single hub, which is simpler, and then easy virtual networking. So it is now one of the main topics on the route. I restarted with troubleshoot. I didn't start with route.
Okay.
Let me see here these other ones. Bunch of AAA stuff is on there, and then NTP, IP, SLA. Yep. Wow.
Do you know of many people getting route? I mean, do you hear going and getting that certification for the routing?
Not a great deal. Oh, there's all our layer 3 technologies. There's all BGP and OSPF. Not a great number. It's funny though when you look at salaries. The salaries between CCNPs and CCIEs are not that different. So it's in the overall grand scheme of things, it's kind of interesting. I think it's a good certification to have. I see a lot of jobs that ask for it. because the problem is you're just not going to get many CCIEs too. There's a lot of CCIEs out there, but there's not enough to. And plus, the second someone gets a CCIE, their cost goes way up.
Yeah, I think there's only about 5 digits of them out there, so it's a few thousand.
There's a good number of them out there, but they're a lot less than what you would think. One of the things we noticed about DMVPN, it does actually require GRE, which means it is Cisco software, because GRE, even though it's multi-point GRE is a Cisco proprietary non-secure site-to-site tunneling protocol. It is, I'm trying to think, maybe it's open. They may have opened it up now, but I'm pretty sure it is not. Oh, that's funny. It looks for the testing, the GRE test. Developed by Cisco. Actually, I think it may now be, it's now open. It is RFC 2784, so they did release it. So you could use, other people can use GRE. But GRE is not secure. So by default, on its own, it can create a tunnel, but that tunnel is not secure. We don't learn how to do it in this particular class, but in CCNP, you do learn how to do a secure GRE tunnel where you run IPsec inside that tunnel. That's what's happening with DMVPN. You basically have IPsec running inside of these NGRE tunnels. So you see here, you've got IP, you've got GRE, and then you've got the original packet that is a passenger protocol, so it becomes data. So it's encapsulated inside of there. It's really pretty simple. It is, you basically say they can be flagged for an optional header, and then you got a protocol to tell you what's being used above that. 0x800 is used for IPv4. The outer IP protocol is actually 47 for GRE, and the fact they mentioned that about 10 times is something you may want to know. The IP header protocol is 47, the number. It is an open standard now, RFC 2748. I believe it actually was always open. I got it confused with CDP and those other protocols, but it is an open standard. It does not have any strong security mechanisms on its own, okay? So it is something to be aware of, that if you want to run a tunnel, it is not going to be secure. Configuring a tunnel, though, is very easy. You just create a tunnel. You say tunnel mode GRE IP. You put an IP address on the tunnel itself. You set your source, which is the actual start of the tunnel on your device, even your public address. You notice here the tunnel IP is a private address, and this is a public address. So the public address source, the destination, which does not obviously have to be directly connected, it's just any accessible IP v4 public address. And then you can also turn on routing across that tunnel. And that's one of the things that's important, because sometimes we use GRE tunnels like this because we want to route over the internet. Well, the problem is we can't route because we can't send OSPF hello messages across here. So there's no way to set up OSPF between R1 and R2. But if I create a tunnel, I can do that and then also still advertise my internal networks in OSPF, and those will be sent across the tunnel because I've got an OSPF connection through that tunnel. Here we see R2's config, and it is just a mirror image. The tunnel source is the local IP, destination is the remote, and then you've got 192.168.2.2. So the two tunnels, they do have to be the same network. And then you run OSPF across it. Mark, I need to take 1 second break, okay?
Go ahead.
Pause the recording. Okay, so commands for GRE again, tunnel mode GRE IP. This is, by the way, where you can change the tunnel mode. Tunnel source IP address, tunnel source destination, IP address for the tunnel. And then optionally, if you want to, you can set up OSPF to go across the tunnel. And then they do that. The show IP interface brief includes tunnel, and you'll see that the tunnel's up. Okay, once it's established. Show interface tunnel 0 will also show you the IP address and the mask on it, and also will show you the source and destination and what protocol is in use. Show IP OSPF neighbor will show you your neighbors if you have a relationship. And there's a neighbor ID, but here's the address that you're connected to, and it's on interface tunnel 0. And then again, like I said, that would actually, all your internal networks would be sent across the OSPF on this tunnel if you had an internal network. So this would be a way you could actually send OSPF networks for your internal networks across the internet through a tunnel. So again, if you're going to do that though and you want it secure, you'd want to run IPsec through that tunnel, or vice versa. You can do IPsec in GRE or GRE or GRE and IPsec. But again, not the droids you're looking for, so it's not this class. Again, show IP brief, show IP OSPF neighbors, make sure the routes are being routed, make sure you got OSPF routes. And again, this is showing the loopbacks here being shared. Pretty easy on that one. Any questions on GRE?
I'm good.
All right, now this one's where we get to some fun. To this point, we have only talked about IGPs, Interior Gateway Protocol. So protocols within autonomous systems. Because we're talking about branch connections, and because we're talking about the possibility of having a dual-homed connection, and a dual-home connection is a connection to more than one ISP, I'm really glad they've added BGP into the curriculum. BGP is an exterior gateway protocol. It is a major portion of the CCNP routing test. What we're going to do in this class is we're only going to really learn about the basics of BGP. It is important to know that BGP is encapsulated over TCP port 179. So it is a connection-oriented protocol. It is a little slow as far as with updates. I used to call, when we were doing labs especially, the BGP was your break protocol. You'd make a change, go take a break, come back and see if it populates, especially if you don't clear the BGP table. BGP is also extremely dangerous, and I'll show you why in just a second. So there's a couple ways of doing BGP. You can use it as an internal protocol, iBGP, or you can do it as an external BGP. So there's eBGP, which is between ASs, and there's an iBGP, which we're running internal on the inside. Now, there's all kind of weird stuff with iBGPs, again, that are not part of this class. We're not going to go over that. Just be aware that it's just possible. We're going to focus on eBGP, which is between two different autonomous systems on the exterior. Now, there's no use to use BGP in this situation right here. If you've got a single homed network, in other words, your company has one connection to an internet service provider, BGP makes 0 sense. There's no reason to run it. You need to make a default static route to your ISP and let them do a static route back to whatever networks they've assigned to you. Simple, easy. Very rarely, very, very rarely would you ever need BGP on single home. I would say almost never, okay? However, as soon as you get dual homed, things start to become much more interesting, because now you have two different paths to the internet through two different ASs. You paid for this because you want the ability that if one connection to an ISP goes down, or if an entire ISP network goes down, you got the ability to get to the internet through the other ISP. This is where EGP works best. There's a couple ways they can do it. One is you can advertise your internal networks to your ISP via eBGP and have them only send you a default route. So in other words, you've got one route out to each one of these, okay? The negative on that one is that you don't have, you may use the wrong default route. For instance, you may decide for whatever reason send everything that this is a better default route than this one. And that would depend, because it may be it is better, but it may also be that you're wanting to go to a network controlled by ISP2, And the default route for ISP1 is the one that's used 99%, or it's used until that route goes down. Well, that's not the best route, because you should just go straight across here. But if you're using the default route only, one of these two will be marked as better. And so you would go to the ISP here, and that's set with all kinds of different preferences. But you go here, then over to the ISP2. So, not the best way to do it. A better way to do it is this. Advertise both a default route plus advertise all the routes controlled by the ISP's AS that you're connected to. That way, if you need to go to ISP to a network controlled by a company connected to this particular ISP, you will have that route and you will go directly there instead of using the default route. If you don't, you're not going there, you'll go out to whichever one of these two default routes have been set as the best route. Additionally, if this network goes down, if this link goes down, then you've also got a default route to go over to anything on AS 6501, 65001, and you've also got routes to the ISP2's 65002. This is probably one of the best ways to do it. Okay. However, this is something you should probably almost never do, and this is what happens when people mess up BGP configuration. You connect the company to BGP, and then by accident you advertise all routes, or you ask for all routes to be sent to you, and then suddenly you've got 550,000 routes trying to come into your router that cannot hold that many routes in your route table. It's for that reason that BGP and configuration of BGP is handled by people who know what they're doing, and they're very careful about it. What we're going to do is very simple BGP. We're going to do literally BGP connecting to one client, to one neighbor, and advertising one network. Okay, so we do router BGP autonomous system number. This is whatever's been given to you by IEEE or ISP or whatever you picked up. In our case, we're just going to make them up for our labs. You're going to set a neighbor IP address and remote AS number. And then you're going to advertise some network. Now, this is not necessarily the directly connected network, and this is where it gets a little weird. For instance, look at this AS. You say router BGP 65000. That's our AS number. The neighbor is this 209.165.201.1, remote AS 65001. And I'm going to advertise this network. And as long as I've got a route to this network somehow, by the way, these B's should not be here, the bold thing that's supposed to be. But as long as I got a route to this network, that network will be advertised to the ISP. You notice I'm not doing directly connected. You've always been taught with every other routing protocol, advertise all directly connected routes. You don't have to do that with BGP. I would personally advertise this route, but it's not something you have to do. In fact, if you look at R2's configuration or the configuration of the other router, you'll see they do actually use what's called network quad 0, and so they just advertise the default route only. So in this case, what's going to happen is this router will only get a default route, and this ISP will only get the route for the 198 network. And basically, it's our first scenario.
Security?
Do what?
Does that have something to do with security?
No, and you can do security with BGP too. BGP supports security, just like OSPF and EIGRP and all, and RIP, RIP v2 anyway. I don't think it has anything to do with security. I think in this case, it's just let's only advertise the internal networks and let's advertise that default network only, and that's it. That's all we're going to advertise. We don't want anything else on the BGP routing table.
Okay, so it's a best practice, is what you're saying.
Yeah.
Okay.
Basically, you're not going to have this will not get advertised in the BGP, so that all the other people doing BGP don't learn about this link right here.
Okay.
They know about this, they don't know about this. Okay. And the ISP knows how to get here because it learned about it, and it will know how to get there. So that's just to keep them having to advertise all these links to their connected companies. That's it. That's how simple it is. You do show IP route. You can see BGP in this case on Company A's router, you've got that default route to come in from here. You've got show IP BGP, and you will actually see what the local router's identity is, the ID is. You'll also see the network and where it learned about it. So in this case, you see this network it learned about from this hop. This, because the hop is quad 0, it means that's local. So in other words, it knows that this is a local network. Okay. Down the road, you would learn about all this local prep and med and some other things. This path is interesting because BGP is a path vector protocol. So in other words, it learns to pass through multiple ASs as part of its metric. Company A BGP connection, you can see here, local AS number. You see its neighbor. And that literally is all there is to BGP for what we are going to do. Trust me, there's a ton more to BGP. There's everything you can imagine, but we are not going to cover it in this class. That is part of CCNP. As you can see right here. Right here in CCNP, we've got BGP relationship, peer group, active, passive, verify, eBGP, yeah, all the way through it. So, and one of the things you want to know is
how often do y'all train for that?
How often do we what?
How often do you provide training for the CCNP?
It really depends on the. I have to get a number of instructors together that want it. So I need, you know, if I can get 8 to 10 instructors that want it, I'll offer it. So that's really what it comes down to.
Okay.
Go ahead and I'm gonna stop recording, Mark, because